How can we solve this math Olympiad problem? What are we to do in order to solve for x? Feel free to pause the video and check this question out. So first, I want you to be familiar with some of the properties of indices. When you have two bases, for instance, let's say 2, to be raised with a particular index, it's not necessary for the index to be the same. If those bases are connected with a product sign, then you can select one base and add their power. Similarly, if those bases are connected with a division sign, you can repeat the same process but with changing sign, as this will be equals to 2 raised to the power of x minus y. And the good thing about these properties is that they work in the vice versa way, which means if this is what you're having initially, you can turn into 2 raised to the power of x divided by 2 raised to the power of y. Similarly, if this is what we are having on ground, you can turn into 2 raised to the power of x multiplied by 2 raised to the power of y. Keep this in mind as we are going to be using them in this video. So let's solve the problem before us. So what I'm going to do right now is just to simplify 2 raised to the power of x plus 3 to 2 raised to the power of x multiplied by 2 raised to the power of 3. And for the right hand side, that will become 6 raised to the power of x divided by 6 raised to the power of 1. And simplifying further, we can have 2 raised to the power of x multiplied by 8, as 2 raised to the power of 3 is simply 8. And this will be equals to 6 raised to the power of x divided by 6, as anything to the power of 1 is still that thing, but anything to the power of 0 is simply 1. Now what I'm to do in this case, let's multiply both sides by 6, and therefore 2 raised to the power of x multiplied by 8 multiplied by 6 will now be equals to 6 raised to the power of x divided by 6 multiplied by 6. Now you notice that at the right hand side, those 6 are going to cancel out, and left over at the left hand side, 8 times 6 is simply 48, and therefore we can have 2 raised to the power of x multiplied by 48 to be equals to 6 raised to the power of x. So what I would love to do right now is just to have constant at one side and variables at one side. So to do that, I'm just divide both sides by 2 raised to the power of x, and therefore I can divide both sides by 2 raised to the power of x, and now I can have 48 to be equals to 6 raised to the power of x divided by 2 raised to the power of x. So what am I to do at this point? What are we to do? What do you think that we can do in order to solve for x at this point? So there's nothing much we can do right now rather than just to introduce the logarithm symbol. So I would like to introduce the log of base 10. Regardless of log of a particular base that you introduce, the answer should result in the same. But I will work with base 10 this time around. And therefore, that will be log of base 10 of 48 to be equals to log of base 10 of 6 raised to the power of x divided by 2 raised to the power of x. Now before we move on, let me quickly review some of the laws of logarithm for you guys. The additional law of logarithm is that when you have log of a certain base a of two variables or numbers regardless, I said x times y, this is simply equals to log of base a to x plus log of base a to y. Similarly, if x and y are dividing one another, it's going to be the same thing, but with a changing sign, and the sign is just going to be negative. Since we already made that for this video, I'm not going to touch that. So right now, you can clearly see that log of base 10 to 48 will now be equals to log of base 10 to 6 raised to the power of x minus log of base 10 to 6 or to 2 raised to the power of x. Right now, I would like to bring the x to the front of the logarithm symbol, as that is allowed. Okay, so therefore log of base 10 to 48 will now be equals to x log of base 10 to 6 minus x log of this 10 to 2. And for now, I will just focus more on the right hand side. So what I'm going to do right now next is just to factor out the value of x. And I can now have log of this 10 to 48 to be equals to x, then multiply by log of this 10 to 6 minus log of this 10 to 2. So I think we are almost there. So we can also for x by just dividing both sides by log of this 10 to 6 minus log of this 10 to 2. So finally, the value of x should be log of this 10 to 48 divided by log of this 10 to 6 minus log of this 10 to 2. So let me type that into my calculator in order to have my final answer. And to 3 decimal place, I have x to be equals to 3.524. 3.524. And this is our final answer. So the exercise I have for you is to prove or to show, testify if this is truly the value of x. Plug in what we have as x back in the question and test both left hand and right hand side and see if that value really works. If you haven't subscribed, please do well subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.